I asked Google Gemini to give me an equation so I can make video on, and I got this. At first, I thought the answer was just equal to 1, but it doesn't work. 1 squared plus 1/2 squared is not equal to 3. So, I thought about it, and I looked at the solution that they gave me. The solution is really nice, so let's have a look. Firstly though, how to even start though? We should be aware that do not multiply everybody by the lowest common denominator, because otherwise we'll get a 4th degree polynomial equation. I think it's pretty scary. Here we have what? This expression in the form of a squared plus b squared. Well, if you look at this right here, it's not nicely factorable unless you use complex numbers. However, we can somehow complete the square in the following manner. Have a look. Imagine if I look at a squared and then we add 2ab and then plus b squared. This right here is nicely a plus b squared, which is really nice. And of course, we added this thing, so make sure we subtract this thing at the end. So we can produce a perfect square like so, and that will tell us that we can add the insides together, x along with x over x plus 1. Okay, and then we can also multiply these things together. So that's kind of think about it. If this is our a, which is the x, this right here, and then the b, which is this. If I do a plus b, let me put it x plus x over x plus 1. Get the common denominator, which is just x plus 1. Right here, I will have to multiply by x plus 1. Let me just put it real quick. Top and bottom, so that will be x squared, and then plus x, and then plus x. So that will be x squared plus 2x over x plus 1. Not necessarily the best. However, if we subtract the 2ab first and then we add the 2ab later, then this thing right here becomes a minus b squared, and this thing right here becomes plus 2ab. So that would be subtraction here. So when you multiply, which is x squared plus x, and then subtract x, well, we don't have this anymore. It's just x squared over x plus 1. And guess what? This is a minus b, and if you do a times b, a times b, x times x, it's x squared, and then the bottom is x plus 1, which matches exactly this thing right here. This is the way to go, and this is the key of solving this kind of to solve this equation. I cannot say this kind of equations because I have to tell you, I'm pretty sure this kind of equations is designed so well so that it works out so nicely when you do that. If it's a plus 4 here on the bottom, maybe not so much. But anyways, let's go ahead and utilize this idea. So, ladies and gentlemen, we'll come back here. This is x squared, and then I'm going to subtract 2ab, which is minus 2x times b, which is x over x plus 1, and then we still have the b squared. And then we are going to add 2ab, which is 2x times x over x plus 1. And that's equal to 3, but I'm going to bring the 3 to the other side, so that's minus 3 right here, and then that is equal to 0. Now have a look. These 3 terms will give us x minus this, and then square, and then we have plus 2 times x squared over x plus 1, and then minus 3, which is equal to 0. And per our computation earlier, this is exactly what we have right here as well. X squared over x plus 1, and then squared, and then plus this thing again, and then minus 3, and that's equal to 0. So in fact, this turns out to be a very nice quadratic equation, but it's just in terms of x squared over x plus 1. And now we can factor it, and before that you can do some substitution. You can say t is equal to this thing, if it's better to factor. If not, you can just look at it. We don't have a coefficient besides 1 here, so it's not so bad. So it's just x squared over x plus 1, and then x squared over x plus 1 to get negative 3, and then this right here we have to get positive 2. So we need plus 3 and then minus 1. So that means this has to be 0 or this has to be 0. So that means x squared over x plus 1 is equal to negative 3, or this right here is x squared over x plus 1 has to be equal to positive 1. And we just have to solve them individually. So for the first equation, I will multiply x plus 1 both sides. So we get x squared equals negative 3x minus 3. And then put these two terms to the other side. And then the rest is pretty straightforward. You have a regular quadratic equation. Because this is odd, let's just use the quadratic formula. Negative b, which is 3, plus or minus square root of b squared, minus 4ac, a is 1, c is 3, and then all over 2 times a. And then let's just continue. That's negative 3 plus or minus square root, that's 9. That's 12. So we have 9 minus 12, which is negative 3 over 2. In fact, we actually end up with 2 complex solutions from here. Put the I to the front, so we get negative 3 plus or minus I square root of 3 over 2. So these are the first 2 answers. As of this one, we multiply this both sides. We get x squared equals x plus 1. Put them to the other side. And then quadratic formula again. So this is negative 1 plus or minus square root of negative 1 squared minus 4ac all over 2 times 1. So that's 1 plus or minus, that's positive 1 plus 4, which is 5, square root of 5 over 2. So we'll have 2 real solutions, and in fact, if you take the positive version right here, we have the golden ratio, which is very cool. Okay, I think this is a very nice way to solve the equation. It's like completing a square in an unusual way, and yeah,